Hello everybody, welcome to another video. I am Chris D'Elia on Code, Tech, and Tutorials. Nerd version of Chris D'Elia. Alright, I'm going to show you today it's an example use of Regex and C++. Something I did recently just for like a project, sort of a side project, just to assist. So I thought maybe this would make a good video, because it is a little hard to figure out at first how to properly do Regex. So I'm just going to go through my intention, my program, its use case, and how I did it, and hopefully that'll help some of you out there that are trying to get an understanding of Regex and how it can be potentially useful. My case here is it relates to Dungeons and Dragons and the spells. So basically, long story short, little setup here. I was trying to find a nice solid list of all the spells with all the details in a format that I could parse. And I found one. I found a JSON format somewhere on GitHub, I think. I kind of forget where I found it. But it had some problems. A lot of the data was incorrect, and it wasn't really fully usable for what I wanted to do, because I didn't really want to have a bunch of incorrect data. So I decided, okay, I'll parse through it, correct all the stuff that needs corrected, and redo it on my own. And initially, I started typing everything out manually, copying and pasting stuff over, and it was taking forever. So what I did is I just like made a spell parser thing. That's what I called it. And I'm going to show you what it does and how it uses it, how it goes through it. This might be a little scattered. I don't really plan this out thoroughly, so that's why. I'm going to launch Visual Studio Code on this folder just to show you all my files. Alright, here we go. So this is what we got. I'll take it from the top here. I started out with a main, which is this spell parser, and made a couple global variables. Now everything isn't necessarily up to standards here. I kind of just did it to get it working. I skipped a few of my normal steps of like optimizing things and stuff, because I was like, I don't care, I just want it to work and then I'm done. So that's what I was going for here. So I'll take it from the top and just walk through this. I think that might be the best way to explain it, but it might also be important to show you where I was really starting from before the code. I was looking at this file. I was looking at this data to parse through. So this is JSON format. I know you can, there's a library for C++, I think it's called JSON, that you can use to also handle JSON data, and maybe that would be better for some cases, but after looking through it, I decided to just build my own, both for experience and getting more used to Regex, and just make sure I'm doing it exactly how I want. So those are my reasons for using Regex. To be perfectly honest, it might make more sense to use a JSON parser library rather than build your own, but I really just wanted to build my own is what it came down to, honestly. It's I don't know, I get pretty excited about coding. Okay, I'm going to move this over here. That way my face is not blocking half the code. So this is just all the spells. Here's a spell. As you can see, it's this is Acid Splash. It's for these classes, and here's one of the data problems right off the bat. It says Rogue and Fighter are the classes that use it. If you look in the player's handbook and stuff, it doesn't list Rogue and Fighter as the casters. So I wanted to strip all this wrong data out of here. Now, that's not to say that rogues and wizards can never cast this spell, because they can. There are archetypes of rogues and wizards as you level up where you can get these spells, but by default they're not listed as casters of the spell, and I wanted to stick to how the books have it. So that was part of correcting all this data, was to make the classes correct. And there's the components are listed in array. Yeah, the classes were listed in array. There's duration, level, material, range, ritual, school, the source where it came from, the text, the description of the spell, and the casting time. So I wanted to pull all this data in and redo it in my new format that I liked better and could work with better. And it just goes through every spell. A lot of this is wrong though. often they get the material wrong, often they get the components wrong, often they get the classes wrong. There was just a lot of problems going through this data. I couldn't parse it in verbatim or use it just as it was. So then I was like, all right, I'm gonna do it all myself. So I did a bunch of them. I typed out a bunch of them. I copied, pasted over, manually checked them. It took forever. I spent so many hours on this. And then one day I was just like, you know, I'm just gonna build something to finish this out. So that's where this comes in. And all right, so that's what I was working with. This is what I wanted to parse in. And I guess I will show you also what I was going for, like what it should look like once I parse it in and bring it into my style. So I was going in to format it like this, putting it in one giant array called all spells, one giant array, and in my way it looks like this. I just have it one big piece of data with name, class, level, all this stuff. As you can see, most of these are strings. Like I turned, instead of classes being an array, it's just strings with commas separated. That's one of the things that would make it easier for me to parse it in or to work with it. I wanted it in a string here. So there was stuff like that, just improvements. This is an integer. This is a ritual is a bool variable, another integer here. Everything else is a string. Components, no longer an array, it's just one string. Material, they had it null occasionally here. I didn't want it to ever be null just because of how I was using it. I wanted it to just say none. So it was another correction. Alright, so that was the intention, to just beautify it, make it better. And this is from a repo called D&D 5e Perfect Spells. So all the new corrected data is up on GitHub if anyone wants this format of all the spells. It's out there. I've already built it, and now I'm going back and showing how. I'll put those links in the description too. And I will make this code public for the spell parser as well. As of this recording, it's private, but that was just why I was building it. Okay, so let's get right into it now of how we want to. Okay, so I want to iterate through this text, grab each one, and push it on to a vector, basically. So I wanted a model of all the classes, which is here. Okay, where's H? Spell model.h. Okay, so here's the model of all the classes. We have all these things. So anytime we parse out a new spell, we want to grab all these things. And as part of the model, I went ahead and built the function to find each of these required. I hope this is making sense. And I got our little reset model because I'm just using the same model over and over in the way I designed it. I thought it would be more memory efficient this way, but honestly it doesn't matter. And also, just each model knows how to find parts to set its stuff. It just seemed kind of cool. So that's how I did my model. Alright, back to the spell parser. Let's walk through this. So I did all my includes, did those in a separate file, just to keep it a little cleaner. There they all are. Yeah, I do use fstream in the end. So we'll leave that there. Alright. So include all my stuff using namespace standard. That's pretty standard stuff, just so I don't have to, type standard : all the time. Alright, so here's my big vector of final spells that I want. As I parse through the file, I'm going to build up this vector every time I finish out a spell. I'm going to push it on here, reset the model and start a new one, push it on when it's done. So by the end I'll have a bunch. Have a string that I use over and over. That's just pulling in the data to search for holding that. And here's each spell. Spell iteration variable is what that means. So anytime I just populate this, push it on to the vector, clear it, populate it again, push it on the vector. So that's kind of the cycle here. And now we get to the main. So yeah, those are the only three pieces of data I'm holding on to. The rest is you'll see. Yeah, you'll see. Crystalia, nerd version of Crystalia will explain. All right, int main. Yeah, I'm not using the argc argv because I don't care. Okay, I'm keeping track of steps. So this is how
this is just how I decided to do it. I decided to go through a switch statement. Depending on which step it's on, it determines what it's trying to find. So first we find the name, we find the class, find the component, and so on. We basically just go through the whole thing and find it piece by piece as we need to. So it starts at step 0, finding the name, and we want to keep track of whether the search was successful or not every time we try to find one. Reason being, let me scroll down a little bit, is if it was successful, we go to the next step and we reset the success. If it wasn't, we stay on this same step and get the next line, hoping that it will contain it. Reason being is occasionally we'll get a line that's just a bracket and we want to skip over those and go to the next line if that's the case, or we get something like this where we don't need that data, we're looking for the S or the V. So there's occasions where it's unsuccessful and we want this success variable to handle that, so it repeats the case if it needs to. And as you will see eventually here at the end of this video, I will run it and show you that it works. Alright, so I have some just notifications for the user, just to tell you whether it worked or not. In the end I could get rid of these, but they were very handy while building, so I could tell if it was successful or not on each little step and correct as needed. Okay, so goes into the first step, tells the user what it's doing. This is really just for my debugging purposes while building. These don't need to be here. Tells you what it's searching through, and then tells you whether it finds it or not, spell name, blah blah blah, if it finds it. So it's only a success. If not, it goes to the next line. It'll tell you it's still step 0. Now looking through this data. And so this might be better said like this. Looking through, yeah. Same thing. It was just so this is pretty standard C++ stuff here, right here, using a switch statement, using a while get line. So eventually this get line will fail, and that's when it finally exits the loop, and that's going to be the very end of the file. So that's the point of that. Now, where am I getting this data to search? I'm getting it through CN. So when I run this, I want to be sure to use a pipe of the file. I mean, I could also do an I stream or an if stream and open it that way, but in my case I chose to just pipe in one. So when I run it, I'm doing command line. I don't know if this is clear to you, but this is the make file for the whole thing. It's not intended to be super perfect, it's just kind of good enough to work. So usually I was just doing make test 1 or make test 2 every time I was running it to see how it was doing, see how I was coming along on the process. And as you can see, make test 1, it builds the main thing, and then it just runs it. So if I did updates, it would just build it and then run my test case right away. So it's intended to be ran with the final target name / as parser, and then pipe in the data. That way CN picks that up with the get line every time. That's how it's intended to be ran. Okay, so we'll go back here. Here we go. So it just does that over and over. It just keeps getting the next line, keeps trying to handle the data, goes to the next step if successful. And as you can see, it just does everything here. It just does all the fields. So I think this is probably pretty obvious. Now I'm not going to go through each of these individually on this particular main, but I will say that once it gets to the end, once the last case is successful, case 12, you hit the default case because it's 13 and it resets everything. It says, okay, now we go back to step 0. We're going to push back the spell we filled up onto that vector. So we start building up that vector every time. Here we go. And we go ahead and reset the model. So I'll show you here, reset model. Basically just resets all the variables. And then it tells the user spell's complete, a spell's complete. So you'll see this a bunch of times as it goes through it. And yeah, it'll just start back at case 0. And if it's at
the end of the file, it'll exit the while loop and exit the program. So what happens when it doesn't fully exit the program, it exits the while loop. Here's the end of the while loop right here. Maybe I should put a comment there to make it clear. End of while loop. Okay, so you get to the end of the file, you've been building up spells, and here's what it does at the very, very end. I didn't build this till after I built all the regex stuff. I'll show you the regex stuff in just a second. Tells you how many spells it ended up grabbing, and it does that by just looking at that spells grabbed vector and doing a size on it, so you can see how big it is. So that's how many spells it grabbed. And then I put this in here just to have an example of what I was going for on the output, and I made a little output. There's other ways to do this, but basically I just created an out stream of a file called outtext.txt and did the required cout, or, well, in this case, outstream, which is an of stream that just pushes it to the file. I had to do a special thing for the ritual because they come in as a 0 or 1, and I wanted them as a true or a false, because those work very nicely in JSON. You want a true or false. So I went ahead and, well, this didn't, oh yeah, that's why I didn't correct the formatting, because it messes up this. I wanted this to stay the same. So I could just format those. Alright. So basically I just do a for loop on all the spells grabbed per spell, and we just make sure this is open. We see what the ritual was, whether it's true or false. If it's true, we call this string true, otherwise we call it false. That's used later down here. That way we're not putting out a 0 or a 1 in the spot. We want an actual true or false. JSON likes that kind of stuff, otherwise it's going to think it's an integer. We want it to be a true or false, not a string, just the actual word true or false. So I had to make that little correction. That's what this here is about. So there it is. We just output each little section of the JSON, and I had to do some escape characters to put in the quotations, new line at the end of them. I probably don't need to explain this in too much detail. If you're confused by it at all, well, I don't know, leave a comment or something, I guess. But then when it's all done, it flushes the out stream and then closes it. So basically this out text should be a giant, decently formatted JSON. It might need a few corrections, but it comes out pretty well of all the data. I basically just need to encapsulate it in the all spells array thing that I was showing you earlier, because it comes out from here to here. Like, that's what it outputs. Each little spell it outputs is that. So there's one, then it does the next one, and the next one, the next one. The only thing I need to do is put them inside of this, which is pretty easy compared to typing out all of this manually. This is over 5,000 lines of spells. So I was doing it manually for a while. Just never again. I'll just rather build something like this. Alright, so how am I parsing these? How am I grabbing these individually? What's the regex look like? Finally we're to this step. Alright, so I'll show you. It's part of the spell model, and it's just all this class. So I just basically built up this class. I built all these finds to custom make sure they found things correctly. It was a little tricky to get right. It really was. So I'm doing an extern of the spell iteration var. This is just the same data as this here. That way I can just populate stuff right to it. So that's global, and that's makes it easy for me to just push stuff onto or change it without having to do extra special things like passing it to each. I don't want to have to pass it to each of these calls, so that's why I made it global instead. Not necessarily the best coding practice. I mean, sometimes it's fine, sometimes you want to do that, but I was just doing it to save my own time, honestly, and, you know, not have to retype the same thing over and over. So let's go through a couple of these. The find and set name. This is the first one that calls, case 0. It looks at the string you passed in. I did it as a const and by reference because this data you're searching through will never change. You shouldn't be editing it, so it safe to do it that way. But the things I do on each of these calls is I be sure to make a regex pattern that should grab the name, but doesn't grab, let me find this, okay, but doesn't grab anything else. I just want to grab acid splash, or on the second one I just want to grab the word aid or alarm. Now one thing I could count on is that these go on in order. So that's one way I built this, is considering that it was passed to you in order. Like you're gonna get this, and then this, and then this. It's not gonna be jumbled at all. So that made it a little easier to stream through it, or iterate through it rather. Okay. So it just looks for this pattern. This pattern looks for a capital letter, because the name of the spell is always capital. And then it looks for any of these characters, which is A through Z, a space, or an apostrophe, because some spells have a little apostrophe. Like Tensor's floating disk, for example. So that was the regex pattern I'm looking for on name. And S matches, or smatches, that's a part of the regex. Matches is an array of strings, is really all it is. So, and then you do a regex search, which returns a bool if it's successful, so you can throw it in an if. So I'm going to search through whatever pattern, or search. This is the this is the string I'm passing in to search through. I'm looking for this pattern. If I find anything, it goes on the matches array. And here we go. So if it comes back successful, I'm just going to go ahead and call the name, the first one, and return true. That way when it returns true over here, called success true, tells you the next thing, ends up going to the next step of finding classes next. So it kind of just repeats this for each one. So next we're looking for classes. Some of these were more complicated than others. Classes was kind of hard because I'm looking at a case of they're on different lines, and some of them I don't want. Like I never want rogue, never want fighter, and definitely don't want this or the brackets or anything like that. So I had to design it in that way. So I made my little pattern here. Classes always starts with a capital letter, so we got that, and then it's always more letters. This could probably actually be lowercase, like so, and it would work fine. But for some reason I have it considering capitals, more capitals too. So that's a pretty basic pattern there. Of course, same thing with the smatches, and we do the same type of search. So these are going to be very similar over here. And my dog's looking at me and whining for some reason. What's up, doggy? Nothing? Okay. She was just out. Don't worry. Don't worry. Crystalia takes care of his animals. And let's see. Okay, so if we find something, we want to compare it to a rogue and compare it to fighter. If it ends up being either of those, because the compare, if it equals 0, it means it's an exact match. So if it ends up matching rogue or fighter, we say no. We return false. So it basically just goes to the next line as per this here, and not going to the next step. It stays on the same step, goes on the next while loop, and finds the next one. But we want to say if it gets past this, doesn't return false, it'll keep going, and it'll say, all right, if its length is greater than or equal to 3, that was just a way of making sure it didn't grab some other random thing. If it gets past this in general, it's probably a legal case, but I put at least something in there to do a little bit of a guard. Oh, wait. Yeah, okay. So if it's greater than or equal to 3, it's already pushed something onto this. Like, because as I showed, I want them as a comma-separated string rather than an array. So if there's already something on it, is basically all this is checking. It appends a comma, space, and then adds the next class, and returns false because, hey, maybe there's more. As you can see, they're all on separate lines by default. Okay. Let's see here we go. And if it's smaller than this size, it's the first one, so we don't need a comma and space. We just
put that on there as the first one with an equals. Notice these are plus equals to append to the string rather than overwrite it. This one would be only the first case, the very first time. It just makes it that. And then if there's more, it starts appending this stuff to it. And then if it gets past all of this, like if it no longer matches anything, it hits this case down here. We want to check and make sure that there's at least something in it. So I just did a size greater than 2, just to have some kind of guard. Make sure it's not a blank string. We return true. When that ended up being good enough to do all the cases. And if it ends up getting past this, then it's another false. So I always have return false at the end in case it didn't work and it needs to go to the next step, or if it needs to stay on the same step and try again. So this ended up working for finding all these cases of appending these classes. Alright, let's look at components. I don't know if I should do all these. I guess it won't hurt to do all these. But for sake of time, I think I'm just going to do a couple more. So we're looking at components. Components is these single character strings of S and V is how they had it. So I had to look at those cases and consider those. But I want the full spelled out word. I don't want an SMVs. I wanted my JSON to have the full word. So what I did is I'm just matching a capital letter, and when we get a match, I'm doing, once again, making sure if the string exists. If the string is not blank yet, because we want to start appending if it is. But if it's a blank string, the first one doesn't need the comma space. It's just, the first word. As you can see, I'm comparing the match to an S. If that matches, then we're going to call, we're appending semantic. If it's an M, we're going to append material. If it's a V, we're going to append verbal. And that's it's very similar to the way the classes did it, because we need to get the first one. Actually, these should be equals, but I guess it doesn't matter because the string's going to be blank anyways. And after the first one, we want to start appending after a comma space. And same thing, as long as there's something there, it's going to return true at the very end if it stopped hitting cases where it's finding stuff after finding some stuff. Alright, let's look at duration. Duration was a little tricky because it sometimes starts with a capital letter, sometimes starts with a number, like it could be 8 hours, it could be 1 minute, it could be, what else were the cases? Let's see. It could be instantaneous, just the capital I, there's an 8 hours. So we need to make sure it found all these, but didn't grab the word duration. We don't want to grab the word duration. And this one's concentration up to 1 hour, and it has a comma in there that we would need to grab. So this one was definitely a little tricky. This one took me a little more time than some of the others to get the regex right. Now this is kind of weird. This probably needs a few corrections, and I've been iteratively making this a little better. But as of right now, it runs good enough to at least get everything accurately, even if some stuff seems odd. Now here's one of the odd things that could be corrected to make it a little better, because as you can see, it has to start with a capital A through Z, or a number. So it's never going to be the word duration, but for some reason I'm still checking for the word duration and making sure it's not that. I think that was just one way I was building earlier and didn't correct it. So that's going to be false all the time anyway. We can just get rid of it and say, okay, if it finds something, let's just append it and return true. If it doesn't find something, return false. As you can see, okay, so it starts with this, and it's followed by any of these. Numbers, characters, a comma, spaces. That seemed to handle it. So this worked pretty well. And then we want to find level. Now level is just a number, a 0 through 9. 0 for cantrips, level 9 max. So that's all we're looking for here on this line of a level. Now this was, let's see, what I have to turn this into a string is one of the things I had to do here, just to be able to push it to, what was I pushing it to? Oh, just for the case of matching. Okay. Because when we do this Regex search, when we get a match,
it saves the match as a string. So it's just like a single character that's a number in a string, but we want it as an integer. So that's why I had to go through all this nonsense of making a string that's just for test, making a num string, making sure this here, make sure that it's only numbers, and if it is, it appends it to the num string, and at the end it turns that back to an integer. Sort of a weird thing, but basically I've used this before in some other programs. You can take any string, you can parse through the whole string, grab all the numbers of it, and you want to make sure they're numbers by using this. This makes sure that whatever you're looking at is a number, and at the end you can turn them back to an integer. That way it's like grabbed all the numbers out of a string and called it an integer. So that's what that does. That's why it looks that way. So that one was a little tricky to get right, but I was able to reuse some code I wrote at an earlier time that worked quite quickly. A little copy pasta code life. Yeah, thumbs up for copy pasta code life. Alright, so materials. Materials was really tricky because sometimes in this JSON it was just the word null. Like this, not a string. And sometimes it was a string of many different things. There was numbers, commas, all sorts of stuff in this one. And we didn't want to grab the word material. We wanted to make sure it was this. We also wanted to grab it if it ended up being the word null, which looks a lot like material in a way as far as regex is concerned, because it starts with a lowercase and is only lowercase characters. Same. So this one I probably spent the most time on, honestly, to get this right. There it is, material, and as you can see it's rather large. So first, it checks if it's the word null. I couldn't find a better way of doing this. I was like, alright, let's just see if the word null exists in the line. If it does, it sets material as none. It returns true. It's like, okay, we got it. It's not. It's a none. And otherwise, if it gets through all this and doesn't return true, it's not a null. There's something there. So we start a new regex pattern, and this took me forever to find a good version of, because there are also on occasion parentheses in that material. It's parentheses, spaces, all kinds of different characters, caps, and I did an A through L and an N through Z. So basically, as long as it doesn't start with an M, because I didn't want to grab the word material, I kept having that problem. But you see, like a morsel of food starts with a lowercase. Almost all of these start with a lowercase if there is actually something. And regex would often grab the word material. So to correct that, I just said, okay, as long as it's not an M, we'll start with something that's not an M, and that seemed to cut out material all the time. I don't think there were any materials that started with the word M. If there were, this would fail on those cases, but it seemed to go through the entire list of spells without failing. So it looks like the materials never starts, the actual material stuff never started with an M. So this ended up working right there to just cut out the M on those. And yeah, I got a lot of C outs here as I was building. I just left them in for now. So also, we're looking for things in between quotations. So a little escape character, quotation, escape character, quotation. And I did this just to see how many matches there were. Just a little for loop outputting. That was purely for debugging purposes. Don't need those anymore. But you know, I'm going to leave them in because maybe I'll debug more. I don't know. So as long as it's not the word material, which it couldn't be, because so this is actually a kind of a dummy case that will never matter because it's always false. So we can go ahead and correct that. But what we're looking at here is we don't want the quotations, but we had to encapsulate them. I forget why. I guess I don't necessarily, since I already checked for the word null. For some reason, when I was building, I decided it was a good idea and tried it, and it worked. So basically what I did is, okay, I grabbed everything, including the quotations, because that made it a little easier to regex the right thing in some cases.
and I just strip the quotes with a substring of, you know, everything but the beginning and end. So that's how I strip the quotes there. I said, okay, take the string temp, make it equal to whatever our match was, and then we're going to take temp and get a substring of it that cuts off the beginning, so it starts at 1 instead of 0. So that skips the first quotation. And length -2, because length doesn't consider 0. Like if it's a string with 10 characters, it's going to say 10. But if you iterate through it, you know, because coding stuff, it's a 0 through 9. So this says 10 instead of 9, and that's why it's a -2, because we only want to go to 1 through 8, for example, rather than 0 through, well, dot length would say 10. So if we just left dot length in there, it would say 10, which would be off the string. So it would be like, it would actually crash the program. So one of like the hardest things to get used to in programming is considering this off by 1 case. It's I wish there was a better way to handle it, but you just kind of have to know it. That when you get a dot length of a string, it tells you the actual length, which looks nice. It's like, all right, 10 characters, it returned 10. But if you iterate through it, you don't go 1 to 10, you go 0 to 9. So that's why there's always these weird things that will often say like -2 when you would think it should say -1, stuff like that. So rant aside, all right, so we strip the quotes and we set the material to that with the strip quotes, and return true, and we're done. All right, then we got a thing to find range, which actually ended up being quite similar to some of the other cases, except there was occasionally a dash in there. So I had to consider that case, and you have to escape a dash with regex. The regex standard, in case you're totally lost and don't understand how these work, you probably need to Google it. You just, you know, open up a browser and go regex C++. You'll find this little reference. Tells you some stuff here. I'm using search, and I'm using, what else am I using? Well, the regex, of course, and smatches for holding results. And there's other stuff you can do here too. I'm not really using it. So this can be helpful. I personally like this site better. There's a lot of tutorials on these. This Geeks for Geeks one seemed okay, but honestly I read through it and I was like, meh, it seemed like it could be explained a little better. So I didn't actually find that helpful. But if you go regex, I think it's wiki, you can find the Wikipedia one, and this tells you all about regular expressions, and this has a lot more info about, let's see here, let me find it, about what all the different stuff does, what all these little characters do, and example matches. You just have to put it into C++ format. Which, yeah, so those can be helpful. Like, yeah, I'll just say that. I don't want to go into too much. I'll just say, I probably should have said this earlier, but like this R means this starts the regex and this ends it. So it's like, I'm going to put some space here just to be clear. So, yeah, this is this pattern right here, and doing this R means it's like a, I don't know what does it mean, I forget the right word, but basically it's verbatim. It's like, yeah, it's an exact match. So you can do your regex with less escaped characters, but some of them you still have to escape, like quotations still need an escape. And this is a special thing of any word character, and this dash here needs escaped. And when things are in these little brackets, like this right here, it's a single character, but I have a plus at the end of it, so it finds as many single characters as possible. Plus being, I think, 1 or more. Is that right? Yeah. So it finds 1 or more of these. It just keeps going until it finds them. But things in brackets are for single character finds. So I think that's enough about that. If you have more questions, feel free to ask in the comments or dig through that documentation, and maybe your question will be answered there. All right.
and so on, and so on, and so on. Special case for ritual, special case for school. When I upload this video, the comment below, I will link this repo so you can check it more carefully if you want. But I think I've went through enough at this point. I'm just going to do a run and we'll call it a day. So look at this make file. So I had already built up a lot of this, and I only needed to do kind of the rest of it. So I made a test 2 that was just the rest of the spells I hadn't completed, and there are 50 of them. And I calculated that by, you know, just counting them, I think. So it should find 50 spells if it gets them all. So I'm going to do make test 1 or test 2 to run it on this test2.txt. It'll go ahead and rebuild it since I made some changes, and parse through it. Shows me all my output for all the C-outs I did for testing, and there it does it complete. Found 50 spells, and it put it on an alttext.txt. So here they all are, starting with spike growth, ending with zone of truth, and it looks like it did each one pretty well there. And you can kind of look through these real quick and see, okay, class is paladin, looks like it's semantic verbal material correctly, set this to none as intended rather than some weird thing. And you can just kind of flip through these real quick and check. There's a couple classes listed correctly, same there. We don't see any rogue or fighter in these listed. So it's looking pretty good. And I can do it with every single spell on that list. Make test 1, this might take a moment, but as you can see, it's going through every single one. 346 found, puts them in this out text, and starts with acid splash now. So boom, there's every single one. Parse through in just a moment. I cannot believe I spent so many hours manually doing this before realizing that, oh, I can just use my coding skills to parse through it. But hey, sometimes you live and learn. And as you can see, okay, on these outputs, sometimes it's looking through just a line that's just a bracket, and it just, you know, skips and does the same step again, looks through, and, you know, it gets to the end of the file here and exits that while loop, outputs it and says spells gathered, all that stuff. All right, well, there you go. There's a use case of regex and C++ to save a lot of time. Hopefully this will help somebody who's struggling with regex. This is probably a little longer than I intended, but hopefully it'll be clear, as clear as I intended, you know. All right, well, if you like seeing my stuff, hearing my voice, you know, subscribe, man. Welcome to the whatever our crew's called. I don't know what our crew's called. I only got 20 subs. You can make it 21 or more, or millions of subs. We're going for millions. Don't forget to give this a thumbs up, leave a comment. I appreciate every comment. If I'm doing something terribly wrong and backwards and could save a lot of time, or you can save someone a lot of time, that's awesome. Or maybe you just want to say, hey, thanks, that's cool too. I appreciate all you guys. And until next time, keep coding. Peace out.